Welcome to the Montgomery County Public Schools Unit 1 Topic 2 review for the final exam. Thank you for watching. So the first one, as I said in the other video, it's a really good idea if you already try the problems before you watch the video, and then when you watch the video it kind of confirms or lets you know which ones you're having trouble with. Okay, so the first problems are asking, write the following expression as a radical. So if we have x to the 1 over 5, that's telling us that we can rewrite it as the fifth root of x to the 1 power, but we don't really need to write the 1 power. So this is the power and this is the root. All right, so then when we go over here, and any negative exponent means it's the reciprocal, so it's 1 over the cube root, right? This is the root and the power, so the cube root of y. All right, over here we have z to the second power and the third root. So we have two options here. We can write the third root of z squared like that, or we could write the cube root of z squared like that. So either one, this or that. All right, over here they're asking, what is my exponent going to be? So here I know this is a 2 because it's a square root. So square root, and in order to go from the denominator to the numerator, I know it has to be a negative number because it reciprocated, and the square root makes it 1/2, right? So the power is 1, the root is 2, so it's x to the 1/2, but it has a negative exponent because of the reciprocal. All right, here we have fourth power, fifth root. So x to the fourth power and the fifth root. Right? So I give an analogy, flower power, so I say the flower grows above the ground and the roots grow under the ground. So this fraction bar, the roots are always in the denominator and the flower power is in the numerator. All right. Over here we have to simplify a bit. So this goes here and there. So maybe using that property, it's called the quotient to a power property. So x to the 2 times 18 over 3, and x to the 1/6 times 18. All right, so 2 times 18 is 36. So 36 over 3, x to the 18 over 6. We can simplify those. X to the 12th, x to the 3rd. Then we have one last step. X to the, because we're dividing, we have the same base and we're dividing, we subtract the exponents. 12 minus 3. So we get x to the 9th power. All right, wonderful. Over here, let's see, we have the square root and a 6th power. So 6th power, let's do this over here. 6th power square root, that actually simplifies to x cubed. So I'm going to change that 6 to x cubed. Wonderful. Now this one is an interesting one because it's asking us for something that's missing. So I might say, okay, well, what can I do to both sides to get rid of this fraction? So I would say, let me multiply by x to the 1/6 on both sides. X to the 1/6. So this and this would then cancel out. And then here I have x to some power equals, so I have to now deal with this guy. And I say, okay, well, they have the same base. If I multiply two powers with the same base, I need to add the exponents. So 2/3 plus 1/6. Now I can't add until they have the same denominator. So I need to multiply by 2 in the numerator and denominator. So I get 4/6 plus 1/6 is x to the 5/6. So my final answer here would be 5/6. Hopefully that process was clear. All right, now we're asked to compute. Basically, simplify that. Tell me what that equals. All right, so let's go ahead and do that. Okay, so the negative tells me it's going to be 1 over. The 1/2 tells me it's the square root. And it's the square root of 81, but in the denominator. So I think, well, what is the square root of 81? What times what is 81? Well, 9. So my final answer for A is 1/9. here I want to rewrite it, and like we said earlier, we could rewrite this two different ways. We could write it with the squared on the inside, or we could write it with the squared on the outside. Now, if I do not have a calculator, I don't want to be squaring 27 and getting some huge number and then finding the cube root of that. It's gonna take me a long time to do that. So I would rather cube root it first, make it a smaller number. So what times what times what gave me 27? Well, 3, and then square 3. 3 squared is 9. So pick the one that makes more sense. Make a smaller number before you make a bigger number. All right. Here, again, we have the negative exponent, and the negative exponent says reciprocate. So here we were in the numerator, and we switched and became 1 over. So the numerator and denominator switch places. Same thing happens here, but the 1 goes down, and the 10,000 goes to the numerator. But it's to the 1/4 power, so the 4th root. So we don't have to worry about the 1. So the 4th root of 10,000 has a 1 with 4 zeros. So I know that's 10 to the 4th power, and the 4th root and the 4th power undo each other, and I just get 10. All right. Number 10 is asking for us to, says Sally solves the radical equation and obtains the solution x equals 25. Is this solution extraneous? So in order to tell if something's extraneous or not, we want to plug it back in and see if it works. So if I plug in 3 times the square root of 25 and see if it'll equal negative 15, here I get 5. 3 times 5 is that, so really I'd like to put a question mark here because I'm asking myself, is that equal? Well, 3 times 5 is 15, and is that equal to negative 15? And the answer is no, they are not equal. So that tells me that this is an extraneous solution. It doesn't make my equation true. So is the solution extraneous? Yes, it is extraneous. X equals 25 is extraneous. And really, this is my justification. I don't need to write out an explanation. I mean, I could say I plugged in 25 and it did not equal negative 15. We could write in words if you want. All right. Then we have Giacomo solves the radical equation and obtains the solution x equals negative 1 and x equals 4. Determine if either of the solutions are extraneous. So again, same process. I'm going to write x equals negative 1 here and x equals 4 there. So let's plug in negative 1. 3 times negative 1 plus 4 equals negative 1. Now in my class, a lot of students were already seeing, hey, this is not going to work because I can never take a square root of something and end up with a negative number. So if I multiply this, I get negative 3 plus 4, which is the square root of positive 1 equals negative 1. That's not a true statement. 1 does not equal negative 1. So negative 1 is extraneous. And it says, determine if either of the solutions are extraneous. So I would say yes, that x equals a negative 1 is extraneous. And then over here, we want to plug in 4 and see if that works. Square root of 3 times 4 plus 4, 12. 12 plus 4 is 16. And on the other side, we have 4. 4 equals 4. Yeah, true statement. All right, so this one's not extraneous. So let's look at the last one. Johnny solves the radical equation and obtains the solution of x equals negative 8. Is the solution extraneous? So let's check. I think for some students you might think, oh, gut reaction. Oh, if it's a negative, it's not going to work. But because it's a cube root, things are a little different. When it's a square root, you can't end up with a negative number. But if when you take the square root of something, you can't get a negative number. But if you take a cube root, what times what gives me negative 8? Well, negative 2. So that one does work. So the question is this solution extraneous? I would say the answer is no. It is not extraneous. And that is your justification, that the cube root of negative 8 is negative 2. Alright, wonderful. A couple more problems. Alright, so we are supposed to sketch the equation below. So I'm gonna give you our table. So if we make a table, we have to plug in very careful values. I don't want to plug in negative numbers because the square root of a negative number, as we just learned, is an imaginary number. So we're graphing on a real plane, x and y. So we want to just use numbers that we can work with. So we can't use negative, but we can use 0. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. And square root of 9 is 3. But then we also have this little negative sign out here, which tells me I'm going to reflect over the x-axis, right? So anything up here is going to reflect down here. And what that looks like on a table is we're doing the opposite of the y's. So these become their opposite. Opposite 1, opposite of 2, opposite of 3. Now I kind of ignore this guy, and these are my ordered pairs. So my ordered pairs are 0, 0, 1. Instead of going up 1, we're going down 1. Over 4, down 2. Over 9, down 3. And then that is my square root function that was reflected over the x-axis. Alright, and then over here we have our cube root function. So we have to use very careful values when we're picking, we have to use perfect cubes so that we can plot them and they're whole numbers. It's a little easier to plot that way. So a nice number to start with is negative 8, because the cube root of negative 8 is negative 2. We just worked it that way. And then negative 1, cube root of negative 1 is negative 1. Cube root of 0 is 0, 1 is 1, and 8 is 2. So then we can go and plot those points, negative 8, negative 2, negative 1, negative 1, 0, 1, 8, 2. Alright, then we want to connect them. It does this little curly guy through there, and that is our cube root function. Wonderful. Alright, so now we want to have some functions that has been translated. Here, we have translations, right? So at my school, we work with this, minus h and plus k. And our plus k values are taking us up and down. And our minus h values are taking us right and left. So we would talk about this and say, well, my square root function went down 3 units, and then it went left 2. So it went down 3 and left 2. So this is my endpoint. And then it has the same dimensions. There was no stretch or compress or no reflection. So we went over 1, up 1, over 4, up 2, over 9, up 3. Let me get this right. 7, up 3. Alright. And then that would be the square root function of this. Now you could do it on a table if you like, and the top of your table would look like this. This is affecting the x's, but it's the opposite. So it's going to be x minus 2. And then you're going to subtract 3 from your y values. And make sure you use very good values of x, like 0, 1, 4, and 9 when you make your table, so that you can find the parent function, the square root of x values, easily. Alright? Wonderful. One last one to graph. This one says we're going to go up 2, and it reflected over, reflect over the x-axis. Okay, I think this one we'll make a table for, just so that we're accurate. Okay, so our good cube root values, negative 8, negative 1, 0, 1, 8, negative 2, negative 1, 0, 1, 2. We're going to reflect over the y. So we're going to do the opposite of the y's. And then we're going to go up 2. So add 2 more. 1 and 0. Great. So now I'm going to ignore this stuff in here, and I'm going to plot those values. So negative 8, 4. Great. Negative 1, 3. 0, 2, 1, 1, 8, 0. All right. Alright, great. So that is graphing. It looks like we have a couple more problems. It asks for what is the domain and range, and what interval are we decreasing, and what is the endpoint. So before I do this, I want to think about what does that look like. So I'm going to pull this down for a second and draw a little graph. So I'm just going to sketch real quick. It says I reflect over the x, so I have my parent function that normally looks like that. But then I reflect over the x-axis, so then it looks like that. But then I shift up 7. So I'm going to go up. Every point on here is going to go up 7. 1, 2, 3, 4, 5, 6, 7. So my graph looks like that. So I think it's important to have an, um, a graph that we can look at before we start thinking about this. So what is the domain? So I want to think about x values. Here's my x. Oh, so my x is here. There's no function, no function, no function until I get to 0. So our domain starts at 0 and goes until positive infinity because my arrow. So I can never really get to infinity, so I put a parenthesis, but I am equal at 0. Another way of writing that is x is greater than or equal to 0. Alright, what is the range? So I look at the y's and I say, I start at the bottom from negative infinity to 7. From negative infinity up to 7, including 7, not including the infinity because that's a concept, not actually a number. So, another way I could write it is y's that are less than or equal to 7. Alright, on what time interval? On what interval is the function decreasing? Well, it looks like, we always read it from left to right, decreasing, looks like on the entire domain. But we have to be careful, because I feel like a lot of students here are tempted to write all real numbers. But that would include all of these too, and it doesn't include that. So, on all of the domains, so it's the same as the domain. On all the domains, so you could write it either way. If it asked you for interval notation, you would, well, it says on what interval. So I would suggest that interval notation would be the best option here. Okay? What is the endpoint of the graph? So the endpoint is 0, 7, 0, comma 7. And that is that. Alright, let's go and pull this back up. Wonderful. So let's solve this equation. It looks like to undo a cube root, we are going to cube it first. So let's cube that. 10 to the third power is 1,000. And that cube root and cube are inverse functions, so they undo each other. And then we have 5x divided by 5. And x equals, now 5 goes into 10 two times. And then 0, 0, so x equals 200. It said solve the equation. Now I want to double check. If I ever solve something, the best bet at getting it correct is double checking and plugging it back in. So if I plug in 5 times 200, I should equal 10. So let's see, does this work? 5 times 200, 5 times 2 is 10, so we get 1,000. And the cube root of 1,000 is 10. Is that a true statement? Yes, it is. Alright, so I know that I got it right, and I'm feeling confident. Wonderful, which is how we want you to feel. Alright, last two problems, and that's the end of Unit 1, Topic 2. It says a bike rider sees a deer crossing the street and puts on the brakes. The distance that he travels in feet can be modeled, this is important because we're going to be using units, can be modeled by the function d of s. Distance dependent upon your speed is 30 plus 5 root s. Okay, where s is the speed of the bike in miles per hour. Okay, so s is speed in miles per hour, and d is distance in feet. Okay. Then it asks us if the bike travels a distance of 58. So this is really important. We need to know what variable. Is 58 the speed or distance? Well, it's nice it says distance, but we can also look at the units. 58 feet, so I know that's my distance. What is his speed? So we're going to plug in 58 here and solve. Alright, so it looks like first step we're going to subtract. We're going to get rid of any, I like to think about like PEMDAS backwards. So we're going to subtract 30 first. And we have 28. And then we're going to divide by 5. And then, let's see, I'm going to move up here. So 28 over 5 equals the square root of s. Now, oh, that is not an s. Sorry about that. Okay, this does not divide evenly, so I'm just going to leave it as a fraction. The last step is I'm going to square both sides. to undo the square root. So the speed is going to equal 28 squared over 5 squared. Oh, that's not a squared. Goodness. Alright, 5 squared. Good. So at this point, I might pull out my calculator and check that. So the speed is 31.36 miles per hour. All right, wonderful. We have one last problem, and that is the end of this unit and topic. So it says the population of a town can be modeled by that, where x is in years. In what year was the population 120,000? So we want to plug that in for p of x. So 120,000 equals 60,000 times the cube root of x minus 1970. All right. So to unfold this, we're going to first divide by 60,000. All right. So when we divide there, we get 2, right? Because if you think about 1,000 divided by 1,000 cancels, that cancels, and 12 divided by 6 is 2 equals, that cancels. The cube root of x minus 1970. Great. Our next step to undo a cube root, we're going to cube. So we're going to cube 2 to the third is 8 equals, this undoes that, and everything inside drops down. X minus 1970. Last step, we're going to add 1970 to both sides. Our final answer, 1978 equals x. So what was the original question? X is the year. So in what year was the population that? So in 1978, the population was 120,000. Wonderful. Thank you for learning with me, or remembering with me. Thanks for watching the video.